So somewhat surreally, this is actually going to be a chapter in the book, and thanks to Derek Stutzman for actually kicking this thing off and now guaranteeing your enshrinement in this particular tome with regards to London 1940. So Derek Stutzman got back in contact with me, and he was very interested in the project, and he was obviously very interested in the shout-out and various other things, and just wanted to get an idea of what this thing was all about. And it's very difficult talking about agent-based modeling because it's so implicit to what I do just in terms of the simulation sense. And then I thought, well, I've got to be able to describe this. And then I went on LinkedIn. Bear with me. The story goes through a couple of twists and turns. And a fellow who'd appeared on one of the early Biota podcasts had a post about a gentleman publishing his winning his intelligent agent or simulated agent prize, his agent modeling prize. And I read the article, and I didn't understand what agent modeling, I didn't understand that this person knew what agent modeling was, which was very curious because I thought, okay, so now I need to describe agent modeling. And the first thing I did when Derek Stutzman contacted me, I was playing with my girls at the time, so the first thing I did was play with my girls. But when I was done with that, I thought I need to get him Simulated Ape, which is the Ape SDK in its kind of rawest game-like form where you can interact with the Ape SDK. It used to have a different name, but the Ape SDK, and get a sense of the narrative of the simulated agents, or at least the complexity of the simulated agents. Now, London 1940, the simulated agents are Londoners. They're actually nearly a one-to-one mapping between actual people in London and the simulated agents. So what you try to do with an agent simulation from the Ape SDK, for example, is your agent represents an entity, a thinking entity, an interacting entity that has a number of different interactions, has a number of different processes, thoughts about those interactions, and builds a character-like description of themselves through this interaction. Now, I don't know if this gentleman, who ironically has a consultancy firm in London, has that in his agent modeling software, but that's what the Ape SDK is about. It's about creating agents that have various senses, various things that they interact with, conversations, picking fleas off other agents, as it might just happen with the Ape SDK. And they go through these kind of complex iterative cycles around day and night, ironically, waking up, doing stuff, falling asleep, involving eating and social interaction and observing and learning the space that they're in and doing a bunch of different things, which they do in day parts of the day-night cycle. And the idea is to take these simulated agents and put them in London in 1940 and give them a bunch of occupations, as they say in England. I would call them jobs, maybe professions or something like that. But anyway, they have a wide variety of possibilities. Now, the aim is currently, let me state this out loud, that there are going to be probably about 100 descriptive occupation hierarchies, which literally describe things like death, economy, education at a tertiary level, these kind of things. And that describes a hierarchy. And within that hierarchy, you have, for example, junior academics, senior academics, and professors, right? Or, junior lecturers, senior lecturers, and professors, or something like that. So each of and within things like textiles and baking and shoemaking and all these different, what I would call occupations here, but I'm to say the word professions, there are implicit hierarchies. And at these businesses, as they exist in the British Telecom's London phone directory for 1940, there are lists of where you could go to get shoes, right? So clearly that might just be just a single person shop, but probably has 3 or 4 people that are in the shoemaking game, or for example, a baker, a bakery. There are probably multiple people that work as bakers in the bakery at various levels. Some of them might just lug the flour in and out and this kind of stuff and get the basic produce in, the eggs and things like that. Some of them might actually be the people that make the dough. Some of them are actually the people that are at the front of shops selling the baked goods. So there are a basic line of agent modeling, which just deals with you're a human surviving in the world in London in 1940. And then there's a wide variety of occupations which add on top of this, which relate specifically to locations in London, where they work, what they do in their jobs, how they move around in their jobs, whether they leave twice a day or whether they just arrive in the morning and leave in the evening, or whether they work in the evening and leave in the morning, or how they do their jobs. And the idea is that rather than just having a series of interactions that look like almost like a model railway, you got people moving to and from, what have you, they have more interactions, like additional interactions. They maintain an internal narrative about the experiences that they have, which means that when they interact with another agent, they have an ability to share their narrative and these kind of things. So agent modeling is, for me, just an implicit thing. And also, it's really interesting how wrong you can get it too. But the idea is that you take a central piece of software here, the Ape SDK, you add layers to that, you run it for a period of time, and you start to see, oh, wait, some of these agents stop moving after a period of time, and they wait for a period of time, and then they start moving again. How do we debug this? So really, I think the model rail analogy is a good way of starting this thing off. You want automata to move between locations, and you want them to have various reasoning behind that movement. But in addition to the movement, they might have interactions, like, potentially there may be violent agents in there which cause bad spirit, or perhaps you have, I don't know, crushing or various other things that occur in various bottlenecks. And behind all of this, you've got data. So the data here are the maps of London, and I'm talking to Bob Mottram about whether we can change the mapping. Now we're just focusing on London. We're not focusing on Folkestone. Unfortunately, I can't find a telephone directory for Folkestone, so we're focusing on London. And that means that we have to try and use the information which I get through a very squirrely means. My hope is that the British Telecom Archives will actually, for this project, allow us to use the data in a normal fashion, as opposed to getting a few pages of data here, a few pages of data there. And we won't even go into the extreme nature of getting data to simulate London. You'd think if you had an open source project, you might have some interest. Let's just say, I don't know, post-COVID, who knows what the world is actually based on. So you then have an issue associated with postcodes, because what the telephone directory gives you is a name, which sometimes instills a profession, i.e., Able Bakery, for example. And then they give you a postcode, which in London is a few letters, a few numbers, a few letters. And you need to understand where that postcode is, which is where things get interesting, because we haven't actually done that yet. That's still on the to-do list associated with simulating London. So you then have a postcode. You then know that Able Bakery existed in this location. Well, it may exist plus or minus 5 buildings. I don't know. I don't know how accurate we're going to get that. I don't think we're going to end up with a street directory. That would be relatively extreme. But the idea is that you end up with 100 different kinds of occupation hierarchies. And then probably within the occupation hierarchies, you end up with maybe 3 to 6 different occupations that exist within that occupation hierarchy. And then it caters to a wide variety of things: shoes, baked goods, death. These running errands, people that move stuff from A to B, which is absolutely critical if you have a bakery, because you need to get the flour from somewhere outside of London into your bakery. And ideally, you have people that do various professions within the bakery to make the baked goods. Or pottery is a good example. You have a variety of professions within pottery associated with actually carving up the clay and getting the clay ready, and then the people that actually make the vessels out of the clay. And then you have some people that use molds to make vessels out of clay. So you have all these different kinds of occupations that are basically built around certain areas. And the hope is that by simplifying this to a certain extent, starting with 100, each of the 100, like I say, 3 to 6, so maybe 300 to 600 potentially. I'm trying for 400, but you know how these things go. So you then end up with this hierarchy. You need to start cataloging behaviors around the hierarchy, around the interaction. And this is where it gets really interesting, because you want stuff to emerge from this thing, right? This notion of emergence is central. So you want to be able to do it without doing perhaps the same level of hard coding that I'm starting to do. And this is the difficulty, is where does the hard coding actually begin? Where does the hard coding end? Are you really dealing with like a model railway where, the agents run on time? Or are you actually dealing with more of an implicit simulation where maybe even you don't need an occupation list? Maybe you don't even need an occupation hierarchy. Maybe you just send the agents to the bakery and hope that the bread is made. So all this stuff is very interesting in terms of, firstly, it's a job for 20 odd years worth of time. And it builds with iterative changes and new data. And certainly to have the data like London in 1940 and the issues associated with where does this data reside, what's public data, what's not public data. This is why I'm doing things like the occupation hierarchy to start off with, because, I'd like to make sure that all the data that I use through this process is all open source and freely available, and hopefully British Telecom in their archives allows that to be done. But if they don't, we've got to be able to have a simulation irrespective of whether we can get the data. And the occupation hierarchy is a good piece of independent work. And then we can start saying randomly, we need a density of bakeries in London from this area to this area. And we don't even have to use the British Telecom directory. We don't even have to use that. We can remove that data entirely and just say we're going to randomly place bakeries from one end of London to the other. And then, of course, you've got things like the trains and stuff like that as well. I mean, you've got all these interesting things where it would be really nice to use actual world data, like what is in the phone directory. But if you don't have to, it doesn't ruin things. It just means that you need a probability distribution over all of London for the various occupations. And then you need to look and see how the simulation actually works out. Have you gotten it right? What metrics can you use to get it right? If half of London starves within the first, let's say, 30 days of the simulation being run, you probably have a distribution of the bakeries wrong. And if the bodies rot in the streets, you probably have a distribution of those that deal with death wrong. And, if there's no economy, you probably have the distribution of bankers, accountants, and all the other things associated with the economic system probably wrong. So you have all these little bits and pieces, and this is where it actually gets quite fascinating. And certainly I do thoroughly appreciate Bob Mottram's interest in various areas and no interest in other areas. And it's for me to actually see that the simulation continues on, irrespective of whether folks like Bob Mottram want to model where postcodes are. So all these things can come together in different ways, and the current issue is that I am spoilt for information. I'd just like to be able to use this information publicly, and that's where it gets very interesting. So my hope is that I've somewhat illustrated to Derek Stutzman what this whole simulation thing is. I've tried to do it in words. Hopefully it'll be in writing as well. And talking about agent modeling, one of the paradoxes that I wanted to talk about a little bit in the writing was this notion of time, that time has many meanings, but there's simulation time, which means the entities do things in a simulated time frame, which means you run the simulation either for an hour or in many cases 1,000 years, which is, the extreme of these kind of simulations. But I try to do it with the Ape SDK on a regular basis just to keep sure that the simulation components are actively working the way that I intend them to work. So that's one aspect of time. The other aspect is you have this project, which is substantial and covers many areas. And you need to work out how your life is going to fit in with that project, how you're actually going to develop aspects of the project. So, like many things within this agent modeling system, the metaphors for the external world are very real, and the descriptions associated with how you divide things up and get these things done over time is also real. So, I will save that for another recording, but this, hopefully, will be of some benefit to some listeners, because I know a number of listeners were wondering what London 1940 would look like, particularly since there was so much detail with regards to Sea Lion, and I don't know, a change of pace is always going to raise certain questions, like what you're actually doing. So I think this is relatively important. I'm going to put it out. Tom Barbalet, Las Vegas, Nevada, signing out.